classes and functions, and I've got the Colab notebook here. All right, so you're going to define your own types of data, your own structures, which is a common thing you do in object-oriented programming. So here you can define a thing called time. Now, I was surprised. In other object-oriented programs like C++, when you define a class, you have to define the methods and attributes of that class. And the methods are the functions that apply to it, and the attributes are the data that's stored in it. But here, they're not doing that. They're just declaring a class time with no more details. And so you can now create a time object called lunch. And if you do the type of it, it'll tell you it's time, and time is defined by the programmer as part of the main function. So that's a user-defined object, and you can print it, but when you print it, you'll just see the object, its address, like any other object. So if you want to give attributes, apparently you just make them up and assign them, which is interesting to me. In other languages, you would have to declare these as part of the object definition. And this suggests, by the way, that not only can you do that, it suggests that I could have lunch.zoo equals tiger. Apparently I can just create anything and add it, and it doesn't complain because it doesn't know what should be there. So that is an interesting, strange property. And here they make a diagram to show you what it looks like in case it's not obvious. Lunch now is the object, and it contains these things: hour, minute, and second. So now you can print it. Lunch.hour is there, and you can take lunch.hour times 60 plus lunch.minute and get the total minutes. Yeah, let me close that window. They're being loud out there. All right. Maybe that'll help. Anyway, all right. And so you can then use the dot operator in an F string. You know, you could have format lunch.hour colon lunch.minute colon lunch.second. And you get this, and you'll notice it's not really correct for time. It should be 01. So you can do that by adding 02D for 2 decimals on those, and then you get the typical time 11:59:01. All right. Here, let me fix this so it's filling up the page correctly. All right. All right. So then you can define printing the time, where it'll format it like this and then print that. So now we can call it print the time of lunch, and you'll get that. All right. So you can return an object, of course. You can put any kind of data. So here I make a time out of hour, minutes, and seconds, and I create a time object and return it. So that's useful. Now I can do time is make time of 11:59:01, and I'll get that print out. And objects are mutable, something that certainly could be either way, I suppose, but they are in fact mutable. So now we could make a time object at the start of something, 9:20, and then we could have a movie, which is 92 minutes, 1 hour, 32 minutes. So we're going to add 1 to the hour, add 32 to the minutes, and then print the time again. And so now it's going to go from 9:20 to 10:52. That tells you when the movie is going to end. All right. Now, you could put that in a function where I'm going to increment time by here's the starting time, there's hours, minutes, and seconds. So I added all these things. All right. And so now I can start is make time. I can then increment time with passing it start and then print time start. And one thing which is interesting to me is it's not obvious how you were supposed to know that the variable you passed in is going to be modifiable on the source. I think the point is objects are passed in by pointers. So what you're really passing in is a pointer to the start, and that's a pointer here. So when it modifies this time, it's actually modifying the object in the calling function, not just a copy. And I think we can see that because here, right, it does increment from 9:20 up to 10:52. So this is not a pure function. A pure function doesn't modify anything except it just returns something. And that's the kind of function that I'm used to. I think it's the kind that's easier to understand. It's not very obvious here that this is going to increment time in the calling function. That's a strange process that I think would lead to confusion. I would think it's a better style to stick with pure functions, and we'll make a pure function out of this later. So here they show you a stack diagram. showing what it's going to work. So here's the start is here, and then I go into the pass it in as time, but the time pointer points to the same object, so when it changes this object too. All right, so if you don't want it to do that, then you could copy it. And apparently from copy, import, copy, you'll get a copy function that can duplicate any object, which sounds pretty good. So now I can set start is make time here, and then I can make a copy, which is the end, because what I'm trying to do is avoid overriding my start function. I want to retain the start time and the end time, so I make a copy of the start time. Now if I print them, they both have the same data, but they're not identical. If I compare them, it'll tell me they're false because the pointers point to different locations. And if you do equals equals, that's kind of interesting. That's also false. That's interpreted as the same as this. And as they point out, that's not extremely obvious. You might think these things would be equal if the contents they contain, if the attributes are the same, but it just checks to see if the pointers are the same. And again, that's the sort of thing I guess you just have to remember when dealing with Python. It's not obvious at all that that would be the case. So now we can make a pure function. We're going to add time here, and we're going to make a copy of the time so we don't change the original, and then we're going to increment the new variable that only exists locally and then return it. This is the pure function, the one I would highly prefer, that does not modify any of these variables coming in, but just returns the value. So now you can take add time to the start time, add 132, and it'll print 1052. So that's better. And the return value is a new object, newly created, and you can confirm that start is unchanged. So I like that. That's a pure function. All right. And like they say, I agree with this. I suggest you write pure functions whenever it's reasonable and resort to impure only if there's a really good reason, because it's just an unnecessarily confusing way to write code. And I was just talking about this in the 142 class earlier. It is real important to write code that's easy to understand, probably more important than writing small code or fast code, because in the real world, you have to keep modifying code, adding new features, and not only you, but other developers have to come in and read your code and modify it. And if you write code that's hard to understand, it leads to all kinds of trouble later. Far more trouble than probably wasting a little bit of computing time would be. So there's a style of programming which I think is a style I often use as prototype and patch. You write a real simple function that does some of what you want, and then you improve it in small increments until it's the way you want. So we're going to discover that the movie starts at 9:40. So if we start the movie at 9:40 and add this time, then what we get is 1072, because we just added to the hours and the minutes, and we didn't include the minutes rolling over at 60. So that's not right. So here's an improved version that will do it. You add the hours, minutes, and seconds. If the second is over 60, you roll over a minute. If the minutes are over 60, then you roll over the hour. So that looks better. And now if you do this one, where you're starting at 9:40 and having gone hour 32, then it actually gets the right time. However, if the arguments are bigger than 60, these numbers here, for example, if you say you give the runtime is 92 minutes instead of 1 hour, you might call it this way. And if you do, you're still going to get a bad number 72 here. Because this thing actually ended up having 2 60s worth, and all we did here was handle 160. So what you really need to do is use the div mod function, which is one of the modular arithmetic functions. And so now we make a copy of start and increment the minute attribute. Okay. And so the minutes are now 132, and you can use div mod. That will divide this by that, and the first variable will be the number of would be the integer. Let's see, carry. What you're going to get is 2 is the overflow. They're calling it carry. So you're going to find 2 60s in the minute, because your minute's going to be 132. It's going to find 2 60s, and then you have plus 12. So that's what you have here. This is the result of the integer division, and this is the remainder. So now you got a function that can do this exactly. Now you can add an hour to the carry to the hour, however many minutes the carry is, and so now it'll work. So that is the improved function. I fixed the seconds by doing div mod. Then I have a carry. I add the carry to the minutes and get div mod, and then I add the carry to the hours. So this should work for any large number of minutes and hours and seconds. All right. And so now, if I go 90 and 120, so I guess 90 minutes and 120 seconds to it, it can handle all that. Okay. So that is the prototype and patch system, where you make a version that has problems, you fix the problems, and just iteratively improve it until it's good enough to surpass your criteria. And in reality, I think a lot of development has to be done that way, because you make something and you use it for a while, and then you discover a problem, or you decide you need to add a feature or change the function to deal with something that changed. So you're constantly patching code, which is why I say it's real important to write code that you can read and that other people can read, because you're going to have to patch it and modify it. But anyway, the other one is design first development, where you think all the problem through theoretically before you write any code, and then carefully write code that will do it. And the thing about this is it only works if you really thoroughly understand the problem. And I must say, in my experience in business and such, you don't really understand the problem. You start doing it and then things change. But, there may be businesses or applications like in science and mathematics where you actually understand the problem and it holds still for you. But I know in business, nothing seems to hold still. So people are constantly calling you and saying, we have to change something. Anyway, so what we're going to do is think of a time object as a 3-digit number in base 60. The number of seconds in base 60, number of minutes, and number of hours, each one of them going from 0 to 59. And so that's one way to look at it. And what they're going to do is you can convert it to integers. And this is what Unix time does. You can just count the seconds, and that's it. Just have a big number of seconds to define your time. Result, a number of seconds since the beginning of the day. And this is how Unix time works. Unix time just counts the number of seconds from January 1, 1970. That's it. It's just a big integer that goes up and up. And that's one simple way to make a time object, and that's what we're going to do here. So time comes in, and so minutes is times hour plus 60 plus time times minutes. That's the number of minutes, right? And the number of seconds is the number of minutes plus the seconds. Okay, so seconds, this is going to take a time, which comes in hours, minutes, and seconds, and turn it into an integer, which is the number of seconds since the start of the day. All right, so that makes sense. So 10101 is going to be 3600 plus 60 plus 1, 3661. That's the number of seconds since the start of the day. All right. And so here's a function that goes in the other direction. You feed in the seconds, and so it's going to use div mod to break it into hours, minutes, and seconds. So you can go back the other way. All right. And so now you can write a much more concise version of add time. Now if you want to add time, you just make time of hours, minutes, and seconds, turn it into an integer, and then return the seconds, and you add, right? You add the time to int of the original time and the time to int of the duration. Now notice I did not change the incoming time object, and I didn't need to make a copy of it because I didn't assign it to anything. I just used it to get the integer number, and the integer number here, so I can return the number of seconds, and it's a pure function. Now I'm going to run that function, which is called add time, and then print the time of the end. So I don't bother printing the integer value, I just print the time of the end. So that's one way to go. And this, another good example, another good thing to learn here, which I mentioned before, is in Python, I seem to spend half of my life converting stuff from one type of variable to another, from integer to string to byte array, and so on. So you get used to this flipping back and forth between different representations of the same object. All right. And so you got functions. You can use type to find out what you've got. Main time are things you've defined. You can use isInstance to check whether something is a measure, is instant of the particular class. If you're not sure whether it has an attribute, you can ask whether it has attribute, which is interesting because remember, I defined an attribute up here called, I think, zoo. So this is going to tell me it's true that it has something called zoo also. No, false. I thought I defined. Oh, but start, I have already defined start by that time. Anyway, I'm not going to worry about it, but it's interesting. You can create the attributes anywhere in your program. You don't have to do it in a function declaration. That's still bothering me. Anyway, you can get rid of all the attributes and their values. Wait, to get them in a dictionary, you can use the variables of start. Okay, and struct shape module. will give us some description of it. Tuple of 2 time. Right, T is start and end, so it's tuple of 2 time. All right, just another way to look at it. Okay, well, that's what I wanted to show you. Let me stop this recording.